Smart contracts are fundamentally computer programs. They are designed to automatically execute the terms of an agreement. These programs run on a decentralized system known as a blockchain. This means no single entity controls them. Their purpose is to automate processes that traditionally require intermediaries. Think of them as digital enforcers of promises. They operate based on predefined rules coded into their structure. This automation can lead to significant efficiencies and new possibilities for interaction. The core concept is simple. Code dictates execution. A useful analogy for understanding smart contracts is a vending machine. When you use a vending machine, you insert money, the input. If you insert the correct amount for a specific item, the machine automatically dispenses that item, the output. There is no need for a cashier or any human intervention to complete the transaction. The vending machine operates based on a pre-programmed set of rules. Smart contracts function similarly. They take digital assets or information as input. They then process these inputs according to their coded logic. Finally, they produce an output, such as transferring funds or registering an asset. This represents a shift towards automated trust systems. Smart contracts are built on blockchain technology. The blockchain provides a decentralized and immutable ledger. Once deployed, smart contract code cannot be altered. Transactions are recorded on the distributed ledger. This makes them transparent and auditable. The decentralized nature ensures no single point of failure. The contract operates as long as the blockchain network is functional. Smart contracts use if-then logic. If conditions are met, actions are executed automatically. For example, if a payment is received, release the digital asset. These conditions and actions are coded into the contract. The contract continuously monitors for these conditions. It acts without human intervention once conditions are satisfied. Using a smart contract involves several steps. First, parties agree on the terms. These terms are translated into code by a developer. This code defines all rules, conditions, and outcomes. Once ready, the code is deployed to a blockchain. The smart contract receives a unique address on the network. Let us revisit the vending machine analogy to illustrate a simple smart contract. Imagine a digital vending machine that sells digital music files. A user sends cryptocurrency to the smart contract's address. The smart contract verifies the payment. If correct, the contract grants access to download the music file. This entire process is automated. No need for manual checks or sending files. The contract handles the transaction, ensuring obligations are met. Another example is an escrow service. Traditionally, an escrow agent holds funds until conditions are met. A smart contract can perform this function digitally. A buyer deposits cryptocurrency into a smart contract. The smart contract holds these funds. Once the seller delivers the service, the contract releases the funds. If not delivered, the funds might be returned to the buyer. Imagine you purchase travel insurance for a flight. This insurance policy could be a smart contract. The contract is linked to a trusted oracle for real-time flight status. Decentralized finance, widely known as DeFi, heavily relies on smart contracts. In fact, smart contracts form the very backbone of most DeFi applications. These applications aim to recreate traditional financial services. However, they do so in a decentralized manner, without relying on conventional intermediaries like banks or brokerages. Smart contracts automate complex financial operations. These include lending, borrowing, trading, and insurance. They enable peer-to-peer interactions, making financial services more accessible and transparent. Lending and borrowing platforms are prominent use cases within DeFi. Users can lend their crypto assets to earn interest. Others can borrow assets by providing collateral. Smart contracts manage these processes. They automatically calculate interest rates based on supply and demand. They also monitor collateral levels. If a borrower's collateral value falls below a certain threshold, the smart contract can automatically liquidate the collateral to protect the lender. Decentralized exchanges, or DEX, are another key component of DeFi enabled by smart contracts. DEXs allow users to trade cryptocurrencies directly with each other. This is done without needing a central custodian to hold their funds. Smart contracts facilitate these trades. They execute orders when specific price conditions are met. Section 5. Transforming supply chains, enhancing transparency and efficiency. Smart contracts offer significant potential for transforming supply chain management. They can be used to track goods as they move from their point of origin to the final consumer. Each step in the journey, such as shipment, receipt at a warehouse, or customs clearance, can be recorded on a blockchain. This creates an immutable and transparent record. All participants in the supply chain, from manufacturers to retailers and consumers, can access this information. This enhanced visibility helps to identify bottlenecks. It also improves coordination and reduces disputes among parties. Verifying the authenticity of products is another critical application in supply chains. Counterfeit goods are a major problem in many industries, from pharmaceuticals to luxury items. Smart contracts combined with technologies like RFID tags or QR codes can help combat this issue. Each genuine product can be registered on the blockchain at the point of manufacture. Its journey through the supply chain can then be tracked. Consumers can scan a product's code to verify its authenticity and provenance via the smart contract. This provides a reliable way to ensure products are genuine, increasing consumer trust. Section 6. Real estate, voting and beyond, other key applications. The real estate industry stands to gain significantly from the adoption of smart contracts. Property transactions are notoriously complex, involving numerous intermediaries, extensive paperwork, and long settlement times. Smart contracts can streamline many aspects of these transactions. For example, the transfer of property titles could be managed by a smart contract. Once all conditions, such as payment confirmation and legal checks, are met, the smart contract could automatically update the land registry records on a blockchain. This could drastically reduce the time and cost associated with property transfers, making the process more efficient and transparent for all parties involved. Voting systems are another area where smart contracts can offer substantial improvements. Ensuring secure, transparent, and tamper-proof elections is a cornerstone of democracy. Smart contracts running on a blockchain can provide a robust platform for digital voting. Each vote can be recorded as a transaction on an immutable ledger. This makes it extremely difficult to alter votes or commit electoral fraud. Section 7. The upside core benefits of utilizing smart contracts. One of the most significant benefits of smart contracts is the enhanced trust they can foster. Traditional agreements often rely on trust in intermediaries or the legal system for enforcement. Smart contracts, however, operate on the principle of code is law. The terms of the agreement are embedded in immutable code on a blockchain. This code executes automatically when predefined conditions are met. This removes the need for a central authority to validate or enforce the agreement. Consequently, counterparty risk, the risk that the other party will not fulfill their obligations, is substantially reduced. Transparency is another key advantage offered by smart contracts. Because they run on a blockchain, all transactions and contract executions are typically recorded on a distributed public ledger. This means that all parties involved in a smart contract, and often the public, depending on the blockchain's design, can view the contract's code and its transaction history. This level of transparency makes it difficult for any single party to manipulate or hide information. It also allows for easy auditing of contractual performance. This openness can build confidence and accountability among participants in any agreement. Section 8. Navigating the hurdles, challenges, and limitations to consider. Despite their many benefits, smart contracts face several challenges, with immutability being a prominent one. While the inability to alter a contract once deployed is a security feature, it also means that any bugs or errors in the code are permanent. If a vulnerability is discovered after deployment, it can be exploited by malicious actors, potentially leading to significant losses. Correcting such errors often requires deploying an entirely new contract and migrating users or assets, which can be complex and disruptive. The principle of code is law becomes problematic when the code itself is flawed, highlighting the need for rigorous auditing. Legal recognition and enforceability of smart contracts remain an evolving area. Section 9. The Horizon. Future potential and evolving impact of smart contracts. The future of smart contracts is intrinsically linked to the continued evolution of blockchain technology. We are already witnessing the development and adoption of Layer 2 scaling solutions. These solutions aim to improve transaction speeds and reduce costs on existing blockchains. Innovations in consensus mechanisms and blockchain interoperability will further enhance the capabilities and efficiency of smart contract platforms. As the underlying infrastructure matures, smart contracts will become more powerful, versatile, and accessible. This technological progress will unlock new possibilities and drive broader adoption across various sectors. We can anticipate wider adoption of smart contracts across an increasing number of industries. Beyond finance and supply chains, sectors like energy, entertainment, and governance will likely find innovative uses for this technology. We may see more complex use cases emerge, such as decentralized autonomous organizations, or DAOs, that are entirely managed by smart contracts. The integration of smart contracts with other emerging technologies like artificial intelligence and the Internet of Things holds immense potential. Imagine IoT devices autonomously reporting data to smart contracts, which then trigger actions or payments based on AI-driven analysis. Experience the first MLM binary commission system written in 100% smart contract on Cryptomulus.com.